Seventh grade lesson 10.1 is population and samples. This is about if you were doing surveys and you wanted to ask questions about something to a lot of people, what you could do to get around having to ask of every person. It'll talk about random sampling or biased samples. It will talk about biased survey questions. And as you start to see it happen, you'll start to recognize it super easily. So I think this will connect fairly quickly. One thing I want to dust off some cobwebs on is averages. This deals with a lot of averaging. Remember, when we average something, we add up all of the numbers in the data set, and then we take that sum and we divide it by however many questions or however many numbers were in the data set. Example. Okay, so if I have this set of numbers as my data set, 6 plus 6 plus 5 plus 8 plus 3 plus 8, if I add those all together, I get 36. And then I would divide by however many numbers are in the set, 1, 2, 3, 4, 5, 6. 36 divided by 6 equals 6. So my average number is right around 6. So that is something we worked on last year, and you'll use that skill within this section. And so the first vocabulary word is the population in sampling. That's all of who you're wondering about. It's like the whole group that you're wondering about. So information being gathered about a group. The entire group that you're gathering information about is your population. It's just that sometimes that's a giant number. If you wanted to find out of 200 people how many liked dogs, you would rather not go ask all 200 people. You'd be at it forever. So the population of what you're wondering about is 200, but you don't want to go survey all of them. So instead, you will do a sample of that population. And that would be part of the group that you're studying, that you want to know about, but you're not going to go ask everyone. So you will go randomly choose a certain number of those 200. So you're asking maybe 20 or 30 people rather than 200. And then you kind of average that out and decide, okay, probably for the most part, this population would on average want this much, or like dogs or whatever. Okay, and so here are the definitions they gave too. The size of the sample and the way the sample is chosen can have an effect on whether the sample is representative of the population or not. So the way you collect it could affect, the way you choose your sample could affect whether you're going to get an accurate depiction or not. And so let's look at this example they give us. A vegetable garden has 36 tomato plants. There's all of them arranged in an array of 6 by 6. The gardener wants to know the average number of tomatoes on the plants. Each white cell, these white cells here in the table, represents a plant, and the number in the cell tells how many tomatoes are on that particular plant. Because counting the numbers of tomatoes on all of the plants is too time consuming, the gardener decides to choose plants at random to find the average number of tomatoes on them. So to simulate the random selection, we're going to roll 2 cubes. So we had, remember, this was 6 by 6. So these number cubes, these dice, they have 6 sides, as you know. We'll roll one of them to find out which row to use here, and the other one to figure out which side to use here. Because we're rolling dice, that's a random answer that's going to pop up. And we're going to do that 10 times and mark which one that it reads. And we're going to mark all 10 of them. So we'll roll the dice. Let's say our first one we roll a 3 and the second one we roll a 4. So 3 and 4 right. Let me highlight 3 and 4 right here. Then let's say we roll a 2 and a 1. 2 on one and 1 on the other. And then we roll a 4 and a 3. 4 and a 3. And then a 1 and a 1. 1 and a 1. A 6 and a 2. 6 and a 2. I don't have any dice available, or I'd be rolling them, and I'd be able to give you a better random sampling. I'm just rattling numbers off. 3 and 1. 6 and 1. I mean, yeah, 6. Well, I've got ones. I got too many ones. I keep saying 1. Let's go 6 and 4. And 2 and 6. How many is that? 1, 2, 3, 4, 5, 6, 7, 8. Two more. 1 and 2. 5 and 5. Is that 10 now? 10. Okay. So now I have 10, and I will want to find the average of those 10. So instead of counting the tomatoes on every one of these, it would take too long. He's going to count the tomatoes on just those particular plants and find their average. So I'm going to add all of those up and divide by 10. Okay, so when I added all those up, and feel free to use your calculators to do all the quick addition and division. Well, the division was easy, it was 10. But for this lesson, feel free to use a calculator for my class. I'm fine with that. I added all those up, divided by 10, and I got 31.2. So on average, the whole garden has somewhere around 31.2 tomatoes. Obviously, it's not going to have 0.2 tomatoes because that's like a fraction of a tomato. They're not growing in cut portions. So 31-ish tomatoes on each plant. Then they say, okay, you did random here. What if you had decided just to count the first row and then not do the rest of it? Just say, this is my sample, this first row. I'm going to count those up and then do the average, and that must be what it is. So I'm going to count this first row up and find its average. Okay, so I actually did this row. They said first row, and I don't know what they mean by first row, if it's this one or that one. I just took that one. So I got 20.5, 20-ish tomatoes on average. So our question would be, what is the better way? Could I have just chosen one row? In a garden, I'm thinking that's probably not a good idea. What if one row is getting more water or less water than the other, right? Better to go random. Let's see how close we were. On the next page, it talks about, it says, hey, I'm going to add up and divide all of them for you. So if we took the whole population, all of the plants, and added them all together and divided by all 36, that would take us some time. Luckily, the book people did that for us. And the number that they got was 28.25. So the average is 28.25. Which one got us closer to that? The random sampling or the one row sampling? 31 is only a couple away from 28, but 20 is 8 away from 28. So the one that got us way closer was the random one. So it's just going to usually give us a more accurate result. It's not going to always give us a more accurate result, but the chances of it being more accurate are better. And so that leads them into explaining to us the difference between a random sampling and a biased sampling. Now, with a random one, out of the whole population, you would be randomly choosing in some way. We rolled the dice on this one. Maybe you're pulling names out of a hat. Maybe you're taking every seventh person off of a list, something like that. A biased sample would be something where you really just focused on one type in that grouping and asked them rather than having it be random to represent the whole population. I think it helps to see examples. So let's look at the example one that they give, and I think you'll really start to see it. Okay, this I'm pretty sure will help clarify things for you. And I find myself circling and underlining things in the questions as I go. And this is one of the things they're going to be asking you in the independent practice and the guided practice in this lesson. Is it random or is it biased? So we have, first example, Roberto wants to know the favorite sport of adults in his hometown. Okay, let me underline a few things first. He wants to know the favorite sport of adults, so he doesn't want to survey any kids, in his hometown. So he shouldn't be surveying people in the town next door. Here's what he surveys. He surveys 50 adults instead of all the people in town, all the adults in town. He surveys 50 adults. Okay, that's good. That's a sample of all. At a baseball game. He wants to know the favorite sports of adults in his hometown, and he asks 50 adults who are at a baseball game. The problem with that is that if he's finding out about their sports, their favorite sport, they're at a baseball game. So many of them very well might have their favorite sport be baseball. So it might not be representing the entire adult population in his town. He's only asking people who went to a baseball game. So that would be considered biased because of who he's asking. They're going to lean a certain way, probably. He's going to get a skewed set of results. Let's look at Paula. She wants to know the favorite type of music for students in her class. Favorite type of music, students in her class. So she needs to be asking a sample population out of her class. They need to be students, not the teacher. And she needs to ask about the music, not ask those people who have hard rock t-shirts on or something like that. So let's see how she does. She puts the names of all of the students in her class in a hat, draws 8 names out of the hat, and surveys those students. That would be random. She's drawing names out of a hat. She didn't let any bias seep into who she's asking. It was a fair choice of who she was going to ask. Everybody had a chance. So hers would be a random sample. So that's how those look. The other part of this lesson is there a bias in the survey question itself? Is there some sort of persuasive words or something that might lead people to choose one way in there that makes the question biased, that might lead somebody to answer a certain way, like you're leading them to that answer? And so that's what you have to watch out for. Again, this is one that the more you see the examples, the easier it becomes. Would you like to waste taxpayers' money to build a frivolous skateboard park? Okay, there's some words in there that are pretty powerful that are going to make people choose a certain way, or that some people will choose a certain way. The word waste, it's kind of a persuasive word. The people who think a skateboard park would be useful wouldn't think it's wasting, right? So waste is a bias word in this case. And frivolous, meaning not necessary, just for silliness. That's another bias word in there. So this question is biased. Would you like to waste taxpayers' money just to build a frivolous skateboard park? That's going to lead people to say, no, I don't want to waste any money. The question's biased. It discourages residents from saying yes to a new skateboard park by implying it is a waste of money. Instead, they could say, do you favor a new skateboard park? Do you favor or do you not? It doesn't have any leading words in there. Do you want to waste money or not? So that would be non-biased. Here's another. Studies have shown that having a safe place to go keeps kids out of trouble. Would you like to invest taxpayer money to build a skateboard park? So they're implying that it's a safe place, that kids are out of trouble. And I mean, maybe that's the case and maybe not. But that now has put into the person's mind that they're asking that and a more positive spin on it. So this one is biased. It leads people to say yes because it mentions having a safe place for kids to go and stay out of trouble. So the best one that's non-biased would be this one. Do you favor a new skateboard park? Yes or no, without leading you to an answer one way or the other. Let's look at these examples too, because like I said, the more you see these, the easier they become. When it comes to pets, do you prefer cats? So that's biased because they kind of lead you like, do you prefer cats? When it comes to pets, maybe which do you prefer? When it comes to pets, which do you prefer? Might be a better way to ask as a non-biased way. This is biased because it leads cats. So you would just put biased on that line. What is your favorite season? They don't say one way or the other, and they don't lead me to say one way or the other. They just ask me straight out, what is my favorite season? So that would be non-biased. So that's just how you do that. They're going to ask whether your samples are random or not, and they're going to ask you whether the questions asked in the survey are biased or not biased. And you'll go through and practice them, and you'll find with each one, this becomes easier and easier. And one thing I notice in the guided practice is they say, what is the mean of this data? MEAN. Remember, mean was just another way of saying average. So when they ask for the mean of the data set, you're looking for the average. Add them all up and divide by how many are in the data set. So if you are not in class, that guided practice, the first one asks you to randomly ask 6 of your classmates their shoe size. And if you're not in class, that's going to be difficult to do. So you may have to make up some numbers on that and then find the mean of that. So that one's going to be a tough one to do, but the rest of them you should be okay to do. Good luck.